This is Intro to Proofs, section 7.1. We're doing progress check 7.3. So in this progress check, we have this relation D on the integers, which is ordered pairs Mn, such that M divides N. And we definitely use the English word instead of the symbol here, because otherwise you're using the same symbol twice, once for such that and once for divides, and that's awful. So this symbol is such that, like this is in this set, such that, that is that. But outside of the set, we'll use that symbol, M divides N, as M divides N, okay? So we'll use that straight line, M divides N. All right, what is the domain and range of this relation? Well, what integers can divide things? So, gotta think a second. So there's certain rules about 0 that we should be careful about. So let me just check on that real quick. Okay, so if you look in your index, you'll see that the definition for divides is on page 76 in your book, beginning of chapter 3. And in that definition, it talks about how the special thing with 0 is that the integer 0 doesn't divide any integer. But unstated there is that all integers divide 0. So that means that since 0 is never the divisor, the domain is all integers except 0. So domain, one way to write that would be all integers, then set minus 0. Okay, the range, because you can say things like 2 divides 0, because 2 times 0 equals 0. So the range is all integers. Okay? Now, is it true that for every non-zero integer, A divides A? Yes. So A divides A for all A in the integers not 0. Okay? And we're going to basically, our universal set is basically integers not equal to 0 right now, because it's just messy, the 0 part. All right, so for all non-zero integers, if A divides B implies B divides A? Question mark? No. For instance, 2 divides 4 and 4 does not divide 2. Okay. What about A divides B and B divides C implies A divides C? Is that true? Yes. Okay. So you can't prove it by example, you just gotta prove it by algebra. So A divides B means that there's some integer A P equals B. B divides C implies there's some integer B Q equals C. Okay? So then A PQ equals BQ is substitute equals C. So then A times PQ, sorry you can't see, equals C. So yes. Now that's all a bunch of algebra, and the thing I want you to learn from this is that this means the relation is transitive. Okay? So this is checking if it's reflexive, this is checking if it's symmetric, this is checking if it's transitive. That completes progress check 7.3.